Question 14 is asking us which system has the same solutions as the system below. So the good news about this is we can use the process of elimination to help us. When we have two of the same equations, that means the systems would have the same solutions. So we're looking for equivalent equations here. All right, let's start with this first equation. 2x plus 2y is equal to 16. Looks great in number 1 because it's identical. So we just need to make sure that the 3x minus y equals 4 is the same as 6x minus 2y is equal to 4. 3x times 2 is 6x, great. Again, we're multiplying the negative 1 by 2 and we get negative 2. So it looks like our multiplier is 2. Only problem is 4 times 2 is not 4, so answer choice 1 is out. Let's look at answer choice 3. We now have x plus y is equal to 16. So it looks like every one of our terms was divided by 2, except for the 16. If this had been an 8 here, those could possibly have been equivalent. So we're going to eliminate number 3. Number 4, let's see what happened here. 2 times 3 is 6, 2 times 3 is 6, 16 times 3 is 48. Awesome. 3 times 2 is 6. A negative 1 times 2 is a negative 2. Number 4 is out. Leaves us with number 2 as our correct answer. Let's just double check to make sure it's true. The first equation is exactly the same, so we don't need to check that one, but 3 times 2 is 6, negative 1 times 2 is negative 2, and 4 times 2 is 8. In question 15, it's asking us to model the table in a function. The first thing that you should recognize is as the x's increase, so do the y values, but they are not increasing at a constant rate. So therefore, we are not looking at a linear function. So answer choices 2 and 4 are out. The next thing that I would do for this question is graph f of x is equal to 3 to the x power, and f of x is equal to 2 to the x plus 1, and see which table of values is true. In answer choice 3, after you hit Control T, that would work out as well. Another less popular option would be to create a list and spreadsheet, type in all this data, and do a regression. This would have been an exponential regression, and it would have also given you answer choice 3, 2 to the x plus 1. I'm hoping for question number 16, you created a table, a little chart, because whenever we deal with coins, this is typically what we do. Dimes and its value and nickels and its value. So reading in the question, it says, John has 4 more nickels than dimes. Because of this, we know that John has 4 more nickels than dimes. So if dimes is x, nickels would be x plus 4. If we look at our equations now, we need to multiply the 10 cents times x, which doesn't look like it's happening in answer choice 1. It looks like it's happening in answer choice 2, not 3, and it's happening in 4. So this piece here. Now we're going to make sure that we're multiplying the 5 cents times the entire quantity of nickels, x plus 4. Remember, x plus 4 is not 4x. Therefore, question 4 is out, 2 is in. Looking at question number 17, the answer choices seem really scary, but they're not that bad. You just need to know that f of x is really the same thing as y values. And I'm just going to write this over any time I see f of x. So what do these mean? Well, we're given a function, a linear one, right here. Graph it and look at its picture. Change the window if you need to. Answer choice 1 says that y is always smaller than 0. So all of the y values are below the x-axis because this is where y is negative. Well, that's definitely not true. And it's not always positive either, because if you see that the graph, as we go closer to negative infinity for our x values, it will drop below down here. So it's not always positive and it's not always negative. But let's see if we put some limitations on it. if x is smaller than 0, so if all of our x values that are smaller than 0, that's these guys over here, then y is always smaller than 0. Well, that's definitely not true. They're smaller than 0 over here, but not there. Let's hope answer choice 4 is correct. This is saying if x is larger than 0, y is always larger than 0. So here's where x is larger than 0. Will y always be above here? And the answer is yes. Question 18 is talking to us, or really asking us about average speed, aka the average rate of change. If you recall, what we've done in class is anytime that we see average rate of change, we take 2 points, make a table, make a table, make a table. We've done this 1, 2, 3, 4 times. This is for answer choice 1, this is for answer choice 2, answer choice 3, and answer choice 4. So we're looking for the greatest value. That would be question or answer choice number 1. Notice how we found the change in the y and divided that by the change in the x values. Number 19 is pretty heavy on vocabulary. So the first thing that I personally would do on this question is create the one variable statistics on your calculator, because it talks about the IQR, the interquartile range, talks about the median, the mean, some of the third quartiles in answer choice 4. So it's just great to lay it out there so you can just look at the numbers. I'm going to start from the bottom up because 3 and 4 don't require many extra calculations other than the one that we did on the calculator. So the third quartile for semester 1 and 2 is what we need to find. So semester 1, the third quartile, that's Q3X, that is 92.5. And semester 2's third quartile is 92. So number 4 is out. Answer choice 3 says the mean, that's the average, and in your calculator it looks like x with a bar over it, for semester 2, which is 87, is greater than the mean for semester 1, 86.8. Answer choice 3 is correct. And just to go quickly a step farther for number 1 and 2 answer choices, I wrote down what the interquartile range was for both semesters, and it was 12, so they're the same. And the same thing happened in number 2. They both had the same median. For 20, we want to see what point can be used to find f of 2. Remember, anything inside the parentheses is x. So when x is equal to 2. So if we look at our axis, we're looking at this axis here. We're going to 2, and as we can see, A lies right on that axis. A lot of people get stressed out when they see questions like this, and my advice to you is don't get stressed out. You know how to model situations. So let's look and see what's happening in a table. Okay, at week 0, it's 3 inches tall. And then from there on out, let's just create what's happening. It's going to grow 2 inches each week. So 5, 7, 9, 11. Now that we've modeled this in a table, we need to see which of our 3 answer choices matches up to this table. If I look at my answer choices, I can see that 1 and 2 are both written just as a general equation, where answer choice 3 is a little different. That's written in the before, now, next lingo. I'm going to start right there. So if you remember from before, f of n is considered the now, and f of n minus 1 is the before plus 2. And it's saying we're starting at 3. F of 0 is 3. Well, we know that part is true. That's this point here. So we need to see if we look before, if we add 2 to get to the next. And yes. So right away, we know that the third function is correct. Immediately, 1 and 2 we can eliminate because we know we have to pick 3. We just need to decide whether or not 1 is accurate. I don't even need to look at 2. I can, but I'm not going to waste my time. All right, let's look. if I put in n, so my n is actually my x value, and y is my f of n, if I substitute in a 0, 2 times 0 plus 3 is 3. How about 2 times 1? 2 times 1 is 2 plus 3 is 5. 2 times 2 is 4 plus 3 is 7. Hey, this is modeling it very nicely. Therefore, answer choice 4 is our correct one. 22 has a lot of words, so let's break it down. The first thing that I recognize is that the cell phone company is charging $60 a month, and that includes a gigabyte. Pretty typical. Most of our plans include 2 now, but whatever. The cost of additional data is 5 cents per megabyte. Next, that's great, is that it tells us what the 2 variables represent. So D represents the total or the number of additional megabytes. I'm actually going to highlight that in yellow because the 2 are connected. Right now, I know that it is 5 cents for every additional megabyte. So I have this expression right here. That would typically equal C, the total charges, except for the fact that we have to worry about the $60. Yeah, we still have to pay that at the beginning of every month. So if we have to pay that, it would look something like this because we have to add the 60 on to every additional megabyte that we pay for. Therefore, answer choice 4 is correct. In question 23, they give us the volume of a cone, the formula for that, and they're asking us to figure out what the radius would look like. So if we rewrote this formula, what would the radius be? We need to use our inverse operations to help us with this. So I'm going to first identify where that r is. You can see a few things going on. First of all, it's being squared, multiplied by h and pi, and by 1/3. So we're just going to undo all of this. I like to get rid of my coefficients first. So instead of dividing both sides by 1/3, because that's not a very popular way to balance an equation, we're going to multiply by the reciprocal, by 3. When we do that, we've gotten rid of the 1/3, or really moved it to the other side, because 3 times a third is 1. I'm not going to bother writing that. And I'm left with pi r squared h. Let's cancel out multiplying r squared by both pi and h next. So we'll divide both sides by pi h. Pi divided by pi is 1. H divided by h is 1. I now have 3v all over pi h divided by pi h equaling the r squared. And lastly, how do we cancel out squaring? We take the square root of the entire side, leaving us with r equaling this, which is answer choice 1. The last multiple choice question, number 24, deals with a sequence. So right away, we know whenever we see sequence or any patterns, table of values is always the way to go. So we need to figure out what they want us to show a table of. And here we can see it's the shaded squares. So let's go ahead and count them up and put them in a table. In my table, you can see that I left a spot for the 0 term. Now, technically, there's no such thing as a 0 term, but when I look at my answer choices, I can see that every single one of these is actually written in is like a linear equation. So if I can figure out what that y-intercept is, when x is 0, I can easily narrow down my answer choices because I have 4 different y-intercepts. Looking at my pattern, it's really easy to see what's happening. To get from 12 to 16, I added 4. From 16 to 20, I added 4. So to get from 12 to the term before, I won't add 4, but I will subtract it and end up with 8. So right away, I'm assuming that my correct answer, just because of the y-intercept, is answer choice 2. We just need to verify that the slope is 4, but really we don't have to do that because it said that for every single one of the other ones. But Just because we're being thorough, to get from 8 to 12, 12 to 16, 16 to 20, we were adding 4, and every time we went from 0 to 1 to 2 to 3, we added 1. So my slope is indeed 4 divided by 1, which is just 4.